Hey everybody, welcome to PC Perspective. I am Ryan Shrout. We are here today with another live streaming event. This time we're actually bringing in a new friend to the PC Perspective studios. We have brought Alex from MSI. Alex, thanks for coming.
Thanks for having me.
We're going to talk about a couple of different things today. I think the primary topic for today is going to be a new motherboard. It's not out yet. You can't buy it yet, right? But it's
very soon.
Very soon? Okay.
Very soon.
Any more specific than that?
I'll go into details, but it's going to be the 28th, which is actually next Tuesday.
Okay. All right. And so this is the MPower series, the Z77 MPower motherboard. It has some unique traits. I know I saw it at QuakeCon. We showed it off and talked a little bit during our hardware workshop as well. And I think you guys kind of showed it at Computex as well. So why don't you go ahead and kind of walk us through kind of the brief overview of the product before we get into some of my questions and some of the user-submitted questions?
Okay. We have a quick overview of the board. It's also shown on the live stream, but this is just a quick overview, if you will, of the Z77 MPower. As you can see, it's a matte black construction. All the PCIe slots are, and also even the memory slots are all matte black. It's got a very unique look to it.
Yep.
With some minor yellow accents.
I like the flat black of the PCB. I don't know how well it comes across in our overhead view, but the non-gloss look of it is actually really nice.
Yeah, it's actually a very good base color for essentially for any type of system build. You can mix and match this with any type of color configuration, but obviously it looks a little bit better with our video cards, especially the Lightning video cards. But just a quick overview. This is actually posted via our social media, Facebook and stuff like that. But this is a quick overview of what the major features are on the board. There's a lot of stuff. A lot of the features are familiar to longtime MSI fans, such as OC Genie, the easy buttons, the voltage checkpoints. All those are very much MSI staples. When it comes to overclocking friendly stuff. Even like the use of the military class components. But there's also new features on this board, such as the onboard Bluetooth and Wi-Fi. A couple of new things. There's a couple of things that are very unique for a Z77 mainstream type of product.
Okay.
One of the things is the 6-pin PCIe.
So this is actually, if we go back to the overhead image, this is right by the primary ATX power connector down here. You've got it is a 6-pin PCIe like graphics card connection.
Yes. It's meant for additional power for the PCIe slots, and if your graphics card is under a heavy load and stuff like that. Yes, most of the power draw is from the PCIe plugs via the power supply. Right. But the power supplied by the PCIe slot still provides an additional layer of stability. And depending on your graphics card, some of the GPU might be drawing power from both the plug and the slot. Right. So this adds as a stability. There are other boards on the market that have like a 4-pin Molex, and those are less preferred, to be honest. At least from my perspective. Okay. But then we also have the
actually, most of the systems I buy or build now almost don't have 4-pin Molex. Like if they're modular power supplies, I almost never put the 4-pin Molex on there anymore.
Exactly. And then we also have the voltage checkpoints, as you can see in the picture, as well as the LED post codes. Both of those are really essential for overclocking. And then we also have a super pipe graphics card. Our graphics cards, I should say, I have an 8mm super pipe. It's something that's really popular for graphics card. But we wanted to make sure the thermal solution on this board was the best we could possibly throw out there. So we did put a 8mm super pipe on the board.
That's one of that's our podcast listeners' favorite feature that MSI ever came up with, right?
Yeah. It's super pipe. It's one of the reasons why our graphics cards is so effective, and I can describe that in a little bit more detail later on, but that's one of the features, as well as the design of the heatsink itself also is very aggressive. Okay. And then there's another shot of the plug area, but there's also one other thing that should be noted, and it's apparent on the test bench. But we really optimize the layout for it doesn't matter if you're into system benching, overclocking, case mod, even just you want to build a clean computer system, right? Every single connection you can think of is on the edge. That's one of the secondary benefits of the the location of the 6-pin, for example, is most of the 6-pin before always used to be mounted above the number one.
PCIe even the
slot,
Molex
right?
ones, they were kind of behind
Yeah,
the
exactly,
headers
right.
on
So
the
then
motherboard,
you have this
right.
awkward situation where you have a great case and then you pull the extra plug over,
Gotcha.
and it doesn't look as fancy, nice, you know. So this allows for a much cleaner computer setup compared to what was available before. And I'm not sure, I think this is the last picture. Yeah. And the last thing is, this is obviously the a slightly different board, but the same configuration. This board, all of our current Z77 boards have a pretty optimal PCIe layout configuration, where if you run 2 dual slot cards, essentially you have an extra slot of worth of space between, so that the airflow doesn't get restricted.
So on this board, we actually, if you go back a couple of slides to maybe the first one we showed, you'll see. Actually, yeah, this one right here. So you've actually got 2 by 1 PCIe slots kind of between the 2 primary by 16 slots. So yeah, normally, you know, if these graphics cards are directly abutting, there are some cases where if you have a GPU cooler that has a taller fan than normal, that it might start to interfere with touching other parts of the other components, that kind of stuff. So you can still put another device in there if you have a by 1 sound card or something that you have to use in that spot. I guess you could use it.
Even a Wi-Fi card, or for example, some of those Wi-Fi cards are by 1 slot and very small, low profile.
And you can still have 2 GPUs in there and do it, or if you don't have that slot there, then you have a little bit better airflow.
Yes, exactly.
Through the system.
Exactly.
So.
But really, I covered all of the major overview stuff. But there's the key benefit of this board, which
right. So this kind of looks like a Z77 board that you guys would have manufactured and sold before today.
Yes.
Right.
Yes,
So
yes.
The MPower branding, I guess, is something different than all that.
Yeah. This is really our first. Well, actually, no, I can't say our first attempt. This is a really aggressive attempt at making a really high quality board.
Okay.
When I mean high quality, and this is also, there's also a question about how boards are manufactured, and it's important for me to explain this process.
Okay.
But I had put up a teaser picture last night on Facebook of this, essentially this screenshot, and let me explain to you real quickly what you see on screen. You see a timer. I opened a stopwatch via Internet Explorer. But this timer has been running for 13 hours now. And normally this board will have had essentially this test run for about 24 hours before it ships. What we're doing differently with this board is that we're doing what's called a 24-hour burn-in test.
Okay.
Essentially, it's called a burn-in test. I'm not going to call it an overclocking test, whatever, because it's very specific. We're running a Prime 95 under a pretty heavy overclock for 24 hours, and every single board will have this done at the end of the assembly line.
So in our testing here, we actually overclocked. It's a Core i7-3770K.
Yes.
We've overclocked it to 4.6 gigahertz, 46x multiplier, essentially, with the voltage bump. And then we ran Prime 95 full load on it. You can see down here that the CPU usage is at 100%. And it's been that way since you came in last night.
Yeah,
we built the system and we did the overclock and we set it up. So it's been running for 13 hours and 20 minutes under this load. The full specifications of the system, I guess we should say, are the Z77 MPower board. We've got a Core i7-3770K. We're using 16 gigs of, what is this, Corsair 1600 C9.
In this case,
memory.
we're only using two DIMMs.
Right.
But we're not using all 4 DIMMs.
And we've got a Corsair H50 cooler, which is a little bit on the older side. I don't think
it's
they
a little bit
actually
smaller.
even sell these anymore, right?
Yeah.
So, but you can tell it's a smaller profile. It's not a super high-end water cooler, but it gets the job done. So we were able to run that, no problems, overnight on that board. So now, how does that implement with somebody who would buy one of these boards? What's that mean?
The key thing here is we're essentially running this test before every board is shipped from the factory. In other words, the board will come off the assembly line, and at the end of the assembly line, there is several test rigs set up, and then every single MPower board made will have this test done.
Okay.
And one of the key things is that you can test all the subsystems and everything else, right? But we wanted to make sure the primary thing about motherboards, which is CPU overclocking, is taken care of. We can spend 20 30, 40 days testing all the subsystems,
Sure.
stress testing everything, right?
Sure.
But a lot of that stuff you don't really need to emphasize too much. But this is something that we can do quick and easy that can ensure the fact that the board can perform reliably, under heavy load.
Now,
out of the box.
Are all the boards going to be tested at a specific frequency then?
Yeah. It's all pretty much an identical configuration.
It's what we have here.
It's basically what we have here, right? But about the only thing is that obviously, as you already know, CPU voltages vary slightly from sample to sample.
Sure.
In our case, we kind of just err on the safe side, so we have a little bit higher voltage. In this case,
yeah, we're running this at 1.25.
Yeah, it's a little bit less.
So at the manufacturing facility, they would run it a little bit higher voltage to make sure that their CPUs...
The power consumption at the in the factory is not too big of a deal. We just want to make sure the board can be stable. That's really the biggest key here.
So what is the benefit of that to a motherboard consumer, like somebody who's going to build a system, right? Like we kind of assume that other Z77 motherboards from MSI and other companies would be able to hit, overclock speed. So what advantage does this kind of offer them?
Biggest benefit for the average buyer of this board is that it greatly reduces the chances of DOA, dead on arrival. You essentially every single board is actually run using components that are installed.
So it actually gets a processor and memory.
Exactly. So it boots up. It needs to boot into Windows. It needs to run this test and stuff like that, and then we take it apart and then we pack it up and ship it. From a manufacturing perspective, not every board is tested. In fact, there's a misconception about manufacturing where people think every single board at the end of the assembly line, somebody plugs it into a system and tests it, which that is actually not the case. When it comes to manufacturing, once you have the assembly line set up, unless there's some deviation, unless there's some quality control, usually once you have the assembly line set up, you usually just do spot checks, and then there's a couple of electrical leads on the board that you can use to check for electrical, grounding and proper grounding, all that stuff.
Gotcha.
But once those checks are done, essentially the board is shipped.
So for other MSI motherboards, and we'll assume other manufacturers' boards, the general case is not that you get hardware installed into it. You would get like I think you pointed out a couple of these leads down here at the bottom that you may have seen on a motherboard already. You're like, those don't really seem to do anything. They're not listed in the manual.
They're not marked. There's like a 2 or 3 prong header that doesn't seem to be.
And so there's usually 2 or 3 of those on a board. What happens is a motherboard is like you've got a lead plugged into one side and a lead plugged to the other side, and it tests for electrical connection.
Exactly. There's basically you could plug different things into like the memory or the power plugs and whatnot, just to make sure it grounds out. Essentially, because if you think about electrical circuits, once a chip is made, as long as all the proper connections are soldered, in reality, it should work out of the box perfectly normal.
And how often would you say that particular process is done in using the leads?
Using the leads is pretty much every single board, but as far as as far as an actual board being physically tested, maybe it depends on the factory. It could be anywhere from 1 every 20 or 30 to upwards of 1 every 50 to 100. It just depends on the. It's all statistics. You basically run statistics, stats analysis on your manufacturing process, right? And as long as everything is within this, spec of the reference design, then we're good to go. Okay.
So then, that was one of the questions. We were soliciting questions for your arrival here. One of the things was, I don't see why this is a big deal, because every motherboard is tested before it leaves the factory anyway. And that's just not the case.
That's not the case. And that's not the case. And that's why, if you read enough review sites, there's often boards that reviewers complain, oh, our first sample was DOA or whatever. It happens, right? And I'm not going to say it never happens. And even if you read user reviews on e-tail sites, same kind of thing is that people complain, oh, this board is DOA. But there's chances that we can't reduce the chance to 0. There's no way to guarantee.
Can't guarantee that
because
it will not be
even there's a lot of stuff that affect how a board is because we can't replicate exactly every single
between
situation.
the time it actually leaves the factory to the time it actually ends up in a user's hands, it's going through distributors, it's going through resellers. A user that may not have the best practices when building a system could be doing all kinds of stuff. So but in general, it's as good as you guys can do. I mean, it would be one thing. To me, it's even kind of impressive because you're not just putting a processor and a motherboard in it and calling it like the non-DOA Z77. You're actually pumping higher performance through it, right? So 4.6.
for
24 hours
and
is pretty good.
It's one thing. The other thing I also forgot is regarding the 24-hour test. The thing here is this: if you read most review sites, and you kind of already know this, we talked about this last night. The one of the things is that you can run a stress test like this to make sure your overclocking is stable.
Right.
But you don't have a ton of 3770s around or CPUs
Correct.
around, and if you need to do a roundup of 5 boards, right? Just to do all the testing and stuff like that. By the time you run through all the tests, it's going to be like 2 weeks, and there's no way you can do a stress test on every single board. Most review sites do a 3 to 6 hour test, right? They don't do like a fancy 12 or 24 hour, unless they have a lot of samples or a lot of time. Or at the same time, if you actually buy the board, you could essentially have a stress test done at home, but then that's kind of like you're doing it on your own time. You don't know what you're getting out of the box.
Okay.
So in a way, we're basically MSI with this MPower board. We're doing this for you in a way. We're doing a critical stress test for you before you even receive the product. I know
Ken was just showing a video up there that was like an example of how the tests are run. It may not be the specific video from the factory.
Yeah, if I remember correctly, the video was shot at a test lab. This is not actually the assembly line, but this is a representative of the type of test. About the only difference between what you see on screen versus what the actual test is done is the use of the graphics card. The graphics card in this case doesn't need to be anything fancy. We just so happens to have. When we first initially tested everything, we just so happened to have the Lightning graphics card on there.
It does match nicely.
Yeah, it does match very nicely. Yeah, but and then there's all the performance stuff aside. Let me close this.
We're gonna stop the timer now. Oh, there it went.
There it goes. There's actually one other cool thing about this board for overclockers, aside from all the other stuff, is there's a feature on this board called Go to BIOS.
So if we go to the overhead camera, it's hard to see. I'll see if I can get my head out of the photo too. Right here,
underneath the heatsink, on the bottom of the heatsink, there's a small black button, and what it is that it allows you to boot directly into the BIOS from any system state. So the system state could be you could be in Windows, you could be powered off, you could be in a boot cycle.
Okay.
If you already passed the BIOS screen, basically it'll boot to BIOS the next time.
Okay.
But all you do is you push this button once, and you go to your desktop, and then you restart the system. Obviously, Windows will shut down, and then the computer will reboot, and it'll end up in BIOS. And you don't have to do anything. You don't have to sit here and be like tap delete key, all that stuff.
Oh, and actually, our BIOS actually showed up on our secondary monitor. Are we showing that now? Okay.
So yeah, but the BIOS, it boots directly into BIOS, and I don't have to do anything. I don't have to press the delete key or anything. And
it's really handy.
It comes in handy. It's not. Here's the thing. It's not meant to. We were talking about this yesterday too. It's not meant to be like a software, like any type of other stuff. But what it comes down to is this: if you're trying to fine tune your system settings, and you have your maybe you're tweaking your all the settings, or you have all the voltage checkpoints used, set up on OpenBench. You want to find out what's best for your system.
I'll go ahead and reset this.
You can basically boot directly into BIOS without you hitting the delete key. It's useful because sometimes you have a display that responds slowly to input. So by the time you see the display come on, you'll miss the boot, the opportunity to get into BIOS. I don't know if you've used in Windows 8 yet, but Windows 8 is even faster in terms of boot with the SSD. Like sometimes the boot screen goes by so quickly that you don't even see it.
That's good, but it causes a different issue. So this is obviously useful for people that have an open test bench, like while they're trying to configure their system and figure out what overclocks they want to do once you get it installed in a case. Obviously, you don't have as quick access to that button there. So that's kind of like an overview. What about pricing and all that kind of stuff?
The board will be available starting next Tuesday. It might take Newegg or E-tail just a couple of days just to get SKUs up and stuff like that. But we are launching this next Tuesday, the 28th. MSRP will be $219.
Okay.
So it's not if you do the math, there's really not a big price premium for the board. we're not charging, like we're not basically charging you, so doing this testing and then charging a huge premium for it. You know, we're actually adding there's a lot of extra stuff too. I didn't even mention this about earlier, but there's also Bluetooth and Wi-Fi on the system. You know, this is something that's comes in very handy.
So it's just maybe you know, another kind of moderate step up above like GD65, maybe, in terms of price.
Exactly. It's about, if you compare it against a GD65, essentially it's about a $30 difference.
Okay.
Maybe a little bit less. There's
depending on how the MSRP actually
turns
out.
And I know we're actively putting together bundles for this with like CPUs and memory as well.
Okay.
So there may be you know, if you're looking to buy one or the other. There's opportunities to make this actually below $200 with the bundles, you know.
That would be good. Okay.
So yeah, and I think there's a lot of questions, right? For the
we did have some questions. Now, you know, some of the questions might already have been answered in our discussion, right? Because they obviously had to ask them before we could really talk about it. So. This one was from Maurice. Is what's the expected price difference between the MPower and the regular series? We just kind of talked about that. What about the warranty difference between the two? Is there any kind of different warranty coverage from an MPower versus like a GD65?
No, it's the same. It's the same 3-year warranty in North America. I know there's a lot of people, and this is my experience with via our Facebook and also different forums. There's a lot of people that have asked about warranty in different regions, and the warranty obviously varies from region to region. Obviously, the warranty in the U.S. is not going to apply to like Europe or South Africa or some other country, you know. But in the U.S., it'll be standard 3-year warranty. There's nothing, you know, different about it. There was talk about doing a overclocking warranty. This was something that we had thought about doing it at Computex. Okay. And then I know it's more than one person asked me about this, surprisingly, because sometimes people just know more information than I know, so, you know, because they're looking this up actively. But But this is something that we definitely want to try to do in the future. The main thing here is that we don't want to do a warranty for the sake of doing one. We want to make sure that if we do have a different type of warranty for overclocking and stuff like that, you know, that it's done right. You know, we want to make sure the program is right, all the elements are in place, so that if there is, you know, make a claim to like, hey, we want to back this up, we want to make sure that there's a comprehensive program backing this up. You know.
Okay. What was the inspiration for the black and yellow color scheme on the MPower and the Lightning series graphics cards? That came from Papa Dragon, who just complimented that he really liked it. Yeah, the yellow accent, if you will, for the graphics card actually was just something that came out of it was just how the development was, you know. There was only so many colors you can use, right? So it was just going with a something that, you know, tried and true from before. Before it was if you look at the sequence, the Twin Frozer coolers used to be all silver, right? Okay. And then what it was with Twin Frozer 3, it became a gunmetal color. Okay. Slightly darker, right? But then the 580 Lightning Extreme Edition had the Twin Frozer 3 cooler with the blue fans, but the shroud was a black shroud. Okay. And then I think once that shroud became black, it just became a very popular thing internally. So then this was the next version, next update, if you will, of the same design. And then the board itself, there's no secret. We're not hiding this fact that this is inspired by the Lightning graphics card. Because people know the MSI Lightning as the best, you know, graphics card for overclocking and stuff like that, right? And there's no secret to that. And then a lot of the board design stuff, a lot of the stuff on the board, I should say, just kind of plays off of that. Plays off of that. But then also a lot of the features were all feedback from all the various overclocking events, such as like the Master Overclocking Arena. A lot of it's feedback from all the things on the edges, all that kind of deal, and stuff like that, you know. So. Okay. Nilbog wanted to ask, what kind of CPU are they using at the factory for these stress tests, and what kind of heatsink? Oh, it's basically this exact same setup, 3770K. About the only key difference is that the CPU cooler is larger. This is a H50. If I remember correctly, they're using like a is there a H100? The H100 is the dual. Yeah, they're using the H100s. It was actually on the video before the ones on the top shelf. So they have a double row. Pretty close to the. Exactly. But the only difference is this is a smaller CPU cooler. So. Okay. Was there, Knight Rider wanted to know if there was a specific reason why you guys went with Prime 95 versus a system that would stress various subsystems as well?
Prime 95 mostly because it's CPU and it stresses the power phases. I think there's many ways of looking at this, but the key here is we want to make sure the board can, the most critical part of the board can be stress tested using a very simple, test.
Okay.
Not complicated, because there's other ways of testing out the subsystems. But in the case of, let's say, audio, LAN, and then USB, all that stuff, the performance, frankly, as long as the chip is soldered correctly, it's all pretty consistent. There's no there's not too much variation, right?
Sure.
Whereas but there's no way to stress the critical part, like I said, the CPU and the power phases around the CPU.
Okay. Another one that is part question, part suggestion, it seems like. Will MSI make their factory QA burn-in BIOS profile and settings available to end users so that they can replicate the known stable settings that the board was tested and burned in against?
We can't. It could be made available, but the problem here is that we can't guarantee that you can replicate that result. If, for example, you have a dud of a CPU, it has a
right.
It's perfectly fine as far as Intel is concerned, but it can't go past let's say 4.3, which is a fairly low overclock.
Right.
If it can't go past 4.3 stable, then you can't replicate this scenario. And as a result, it becomes like, hey, we can make this profile available to you, but then if your CPU can't do that, then it becomes a problem for us. In terms of what we essentially would basically promise but not deliver.
Right. This one wants to know where does MSI see the military class component theme heading into the future? Is it cost effective to integrate even higher quality components than what is currently being used by MSI or others on high-end and enthusiast motherboards?
As far as the component use, what it came down to was, at least to me, this whole burn-in testing was just a next step in terms of what we've done in the past. Before it was marketing campaign, which is military class.
Sure.
And then we took the extra step of making sure the components meet a higher electrical standard than your average, what you can averagely buy in the industry, I should say.
Right. And
then now we test the entire system. Frankly, at this point, it's just a matter of introducing higher quality parts. At least from my perspective, and this is not official, company stuff, but at least from my perspective, I essentially see you can do higher quality parts. So you could keep, you could do less with, you could do more with less from a power phase or design perspective. And then you have the other type of user where they want the quantity, maybe not so much quantity over quality, but just more quantity, more power phases and stuff like that. But one of the things, and this is at least my opinion, is that the CPU performance nowadays is very consistent. It's not like it's not like before where like extra power stuff makes a bigger difference.
Gotcha.
Nowadays it's very easy to do like a fairly aggressive overclock, and the performance is pretty consistent across the board. But
there's not a variance in the overclock ability of any
so if you could have a 12-phase board CPU power, for example, like this, or you could do a 68-phase, I mean, some random number, right? And all you're doing is you're just increasing the cost of the board, but you're not really getting that much more overclocking performance out of it.
Let's see. We addressed the D. Dell ones about. He was asking about. He's the one who made the comment about since motherboards are stress tested at the factory. Anyway, we talked about that. Manarelli and Narbar asked, why not sell a CPU motherboard combo that basically the processor that you tested with on the motherboard with that motherboard? That way you can actually guarantee that 4.6 at this BIOS setting.
Because we would essentially be selling an Intel CPU. That's what it comes down to. We would move from a manufacturer and we start becoming like a computer reseller.
Right.
We essentially would have to be, we would be liable for the actual CPU that we sell you as well.
Okay.
And that's one of the problems. The other thing also is, let's say for whatever business reason, Intel decides to not sell a K-series CPU in North America, right? But then if we bundle this, and we essentially can't sell this as a bundle, board and CPU. There's a lot of other reasons, a lot of different reasons for not being able to do that. But what it really comes down to is that we're trying to make sure that we deliver the highest quality product on the motherboard side. to make sure you have the best quality, product, there.
Okay.
And we're trying to improve what we can control.
Right.
And because we don't make the CPU, we can't control that aspect of it. So it's something that we leave it up to the end user. But as I mentioned before, frankly, CPU performance nowadays is very good. So I'm not really worried about the CPU performance, or at least that aspect of it.
Okay. Well, if you have any other comments on the MPower board, we can talk about that, or we can move on to a quick overview of the graphics card side.
That's kind of it. I mean, actually, it wasn't mentioned, but as far as this test configuration is concerned, and one of the other things is that the heatsink of the
for the MOSFETs?
For the MOSFETs, the power phases.
Yeah.
It's actually designed so that it's for a low airflow condition, such as if you were to run an actual CPU water cooler, CPU, cooler.
So like we were doing right here, if we switch it overhead, there's no airflow in this area at all. The fan behind it is actually blowing away from the motherboard anyway.
Yeah,
so.
there might be, if you have a case with positive or negative ventilation, depending on how you have it set up, you might have airflow going across, but there's nothing that's actively cooling it down.
Okay.
So this is something that it's useful, and plus it looks very aggressive too. So
Yeah, no, it's nice. And like I said, the matte finish I know is a little bit harder to do in production for a PCB.
Yeah.
But I definitely I do like kind of the way it looks. So. Okay, let's bring up a couple of the little diagrams that you had brought for your graphics card, and then I am going to prepare here for the giveaway as well. Don't forget, guys, stick around. We're gonna right after we get done talking about the graphics card portion, we're gonna give away one of these MSI test benches.
Yes.
Some assembly required.
Yes.
It's not super easy to assemble. The directions aren't fantastic, but if you have questions, we can help you.
Yeah.
And then we're going to give away a GTX 660 Ti.
Yep.
Graphics card as well. So, if you want to go ahead and start, let's talk about
the graphics card stuff. I think the slides are I can use this.
We'll figure it out.
The graphics card. People already know the twin fan design. It's pretty common, right? But MSI has been doing this since the GTX 260 or 275 days. That's quite some time ago.
Yeah.
And it's a pretty proven design. You have essentially we have a nickel plated base plate. The base plate is made out of copper, but the key here is the heat pipes. The heat pipes are, the largest ones are the 8mm super pipes on the outside, as you can see here.
Okay.
And then the 6mm pipes on the inside. And one of the things and this is where users need to be careful, the heat pipes themselves are actually soldered to the base plate. So some of the designs out there, there's a heat pipe, but there's a base plate, but they're not soldered together. So the heat transfer is not optimal.
Okay.
So as a result, it takes a little bit. It essentially, once it heat soaks, it doesn't transfer heat fast enough away from the design. And then the other thing is the obvious thick density as far as the fins are concerned. For the heatsink.
Right.
This is pretty straightforward as far as the design is concerned, but it's a combination of all the stuff that makes the twin frozen cooler effective. It's not one thing or the other. It's not going to be the heat pipes that make the difference. It's not going to be the base plates, but it's a combination of all the stuff added together that make it effective. We have the GTX 680 Lightning here, but excuse me. This is an exploded diagram of the back of the Lightning with the PCB exposed, as well as the back plate and also the GPU reactor. GPU reactor was something that we first introduced on the 7970 Lightning, but
I know Josh talked about it on our podcast.
Yeah, the key here is the GPU reactor is not meant for you to. It's not. I guess it's not really meant for air cooled setups.
Right.
You're going to get a couple of megahertz, max versus whatever you can get normally, right? But the key here is it's for LN2 if you're into extreme overclocking, stuff like that, and. To think about the GPU reactor, really, there's one thing in commercial audio commercial audio video stuff that is immediately relatable, which is a power conditioner.
Okay.
Power conditioners for home audio systems. It's not meant to be like, it's kind of a surge protector, but what it does is that it takes the electrical signals, like the current coming in that's often up and down because of all the stuff that's connected on the electrical grid, and it smooths out the currents. And same thing with GPUs. If you think about a power supply, there's really, it obviously reduces the power down to what you can use for the graphics card, right? But it doesn't. There's nothing to clean out the power.
Gotcha.
There's no true filter, if you will. So the GPU reactor is meant for. You can see it as that, as a essentially something that's cleans up the power going to the GPU itself, and it's mounted on the back of the PCB where it's physically the closest to the chip.
So yeah, if we switch over here, you can see our demo model of that there. It looks interesting.
Yes.
It's like, it stands out as something that is obviously not seen on other graphics cards.
Yeah.
It's obviously, you can see this video card has the matching, oops, here we go, black and yellow color scheme too. This is during the workshop when I wore my Batman t-shirt.
Yeah, exactly.
Well, so.
That worked out very well, actually. And then the voltage checkpoints on the card allows you to have the little we have this little probe connecting points that you could just mount. And if you're trying to make sure that the voltages for the graphics card is stable, you could just have your multimeter set up, and then you could do all the desktop benching. You don't have to physically put your probe somewhere. You have an extra pair of hands.
Right.
So that frankly, it's kind of, it gets a little bit tedious, annoying. If you do this a lot. And then really the design of the graphics card, if you look at the Lightning, one of the things I don't mention this very often, but our Lightning, starting with the 480 Lightning, the layout of the PC, actually, sorry, no, even before that, with the 5870 Lightnings, and then the 480 Lightnings, the PCB had this very simple design where the power phases are all stacked up on one side. Depending on the card, as I know over here, but the power phases are stacked up. The memory modules is around. It's a very simple design, and then pretty much ever since the 5870 Lightning and the 480 Lightnings, everybody else has been copying this particular layout. There's a lot of enthusiast cards that have basically adopted this identical layout from a PCB design perspective. But for us, it's one of the most effective things. And then you can kind of tell, but this has a full cover heatsink. It covers all of the modules, all of the.
I was trying to look to see if it was photoshopped, like if things were being photoshopped out, but not the case. Yeah,
the screws are actually mounted on the back side.
Okay.
So the back plate, there's screws that go all the way through. You can actually see it here. The screws are over here. But it's again, just like the thermal design twin frozer, it's a combination of stuff that make the graphics card effective. It's not going to be one thing or another. You can have great power phases, but if its cooling is substandard, right? There's kind of like, it's not as good. There are pros and cons to like an open design. Obviously one of the cons is that it deposits heats back into the case. But I kind of see it this way: it's not going to be a deal breaker for you unless you are you're trying to run a really silent PC.
Gotcha.
Stuff like that.
All right.
And and then the last picture is the GPU reactor.
That's a close-up of it?
Yeah, a close-up of it. It's really, it's just a board with a bunch of, essentially capacitors on it. But the LEDs light up as it's powered on. So when you have the when you have the card powered on, there's a blue light coming from the back. It does look like a certain reactor design from another comic that shall remain nameless for copyright reasons.
Steel person.
Yes, steel.
Steel adult male.
Steel infused with, actually, no, that's the other way around. The element infused with carbon is steel. There you go. So yeah, that's it.
We're back to the MPower board. So what we'll do is I'll go ahead and give away the secret of how we're going to give away the two products, again, this and the 660 Ti.
Yeah.
Everybody needs to send an email again. If you were here for our last live stream, it will be very familiar to you. You want to send an email to contest@pcper.com. Contest@pcper.com. And if you send that email right now, you've got a few minutes. We're going to talk about a couple of other quick questions that we had come up. But I want you to leave us a little bit of feedback about what you thought about the event. But in general, your email into that address from this point going on is going to be enough to enter you into the contest, right? So we'll be able to filter through that. We'll pick a couple of random winners for the graphics card and the test bed. Should be good. Contest. There it is. We put it up there on the feed. Contest at PCPer.com. So I'm sure I'll see the emails start rolling in. So this is a very. We had a question from Jason Booth. It's very large in scope.
Okay.
All right. And I don't know how accurately you'll be able to tell us this. How long does it take to produce a board from design through production? Not just like on the production line, but from like when you guys got the idea for this board, from when the time next week it's going to be on sale.
To throw out a very, well, actually this is both very accurate and also very vague, because if you look at board design from a chipset level, a lot of it has to do with what is provided to us, let's say by Intel or by AMD.
Sure.
You know, if you read PC Perspective long enough, you'll know that hey, there's delays in implementing stuff. You have multiple companies, multiple levels working together. So
that's true.
So having said that, generally speaking, it's about 6 months. It's about 6 months from the time we get the chip, you know, the engineering samples to once we have a reference design for the board, and then we start qualifying stuff, you know, because you have, it's just a graphics card, you have a reference design, but then once you start adding new stuff, it becomes more and more complicated. You have to test, and along that, if there's a new memory configuration like turbo channel, for quad channel, or whatever, you know, even if there's a new memory controller, you have to qualify all of the memory stuff too. So it's not a, hey, just throw in this memory and it works. There's a long, complicated process behind there. There's every single board that we make, it doesn't matter if it's a $300 board, if it's a $100 board or $50 board. There's a long list of memories that we have to qualify, and the faster the memory or the newer the module, usually you spend more time qualifying that.
Right.
And that's really the nitty gritty stuff, you know. So generally speaking, it's about 6 months.
Does the motherboard world work in the same as the graphics card world, where Intel will give you reference kind of design specs for motherboard?
Yes.
Maybe you put out your first Z77 offering that's very close to that, and over time you find ways to adjust and make your own unique product, kind of like on the graphics card where, you know, when the 680 comes out, everybody has the reference card with its own sticker on it, essentially. And then over time we start to see things like the Lightning become developed and released.
There is a reference design, but the reference design, to be honest, nobody would buy. Because it's basically bare bones. Whatever the chipset has functionality-wise, whatever the CPU has functionality-wise, and their basic, what Intel considers a basic power phase requirement. So all the low-end boards essentially is, I think it's like 3 or 4 power phases. If I remember correctly, that's the minimum as far as the reference design is concerned. But then beyond that, you basically, once you get into overclocking and stuff like that, you start adding costs and stuff like that onto the board. So there is a reference design, but it's usually really just to qualify the whatever original design you have. Because just kind of like a graphics card, you have a let's say this is a reference design graphics card. You essentially have used that as a baseline for measuring performance of your custom designs from an electrical perspective, memory-ish perspective, power delivery, etc., etc. You know, there's a finite amount of power coming in from the wall socket, right? It's how you use that in an efficient manner that really sets you apart. So it's you know, there's a long back and forth process.
If you guys have any comments in the chat room, be sure let us know. We'll answer a couple of those. And again, as I remind you guys, that the email address is contest@pcper.com. I'm going to give you a couple more minutes to send those in. And we're going to use the magic of random.org.
I use that too.
To pick
amazingly,
the winner.
Amazingly, I use that to administer my own contest too.
Yeah.
So.
Random.org is great for that. I hope it never gets compromised, otherwise I'll be totally out of ideas. So in the chat room, let's see, do we have anything else that kind of came up over the course of the event? The SLI questions, a lot of people in the chat room are actually answering their own questions in their forums.
Awesome.
So, I mean, what is the, if we go back to the MPower, kind of the reason for the event, the launch of the brand new product, what is kind of like the one primary takeaway you want people who watch this video to come away understanding?
The biggest thing is you are essentially getting a product that's been proven. I remember the analogy. I love using car stuff because I'm a car guy at heart. If I wasn't doing this, I'll be driving cars illegally on many roads that shall remain nameless. But the biggest thing is BMW, for example, had an ownership experience where if you pay an extra, was it $3,000 or $5,000, they basically fly you to the assembly line, assembly plant in Germany, and at the end of the assembly line, basically after the car's spot check is done, you could drive the car on their BMW's test track. Your actual car that you're going to own,
right.
And you get to drive it on the test track. You can either you have options too. You can either have the factory driver that fits he or she is available to drive the car for you to show you what the performance is, or you could drive it yourself and try to see if you can improve your times, right? But it's part of that ownership experience. But I know it's an extra cost. But imagine if a manufacturer for a car, right, after your car rolls off the assembly line, you can know exactly what the performance is of the car, not just rated performance, but exactly what it's how it performs. I know you had mentioned this regarding the Corvette, how the assembly plant is local, and if you for a few $100, you could essentially customize the manufacturing process at the end. You're the first person to sit in the car, right? And what we're trying to do here is add something new and different to the world of overclocking or performance. You know,
it's not cost efficient to send somebody to Taiwan.
Exactly, or China even.
Or China,
you know.
to say, here's your board, right?
Yeah, it's not cost effective, but at the same time, we want to make sure that the performance is proven. And the key here is we're not trying to do all of the overclocking for you, right? There's certain things that we just can't do ourselves, whether it be time or otherwise. And there's a lot of smart users out there in the world in terms of how they their knowledge about computers, and we want to make sure that everybody knows that if you buy an MPower board out of the box, it's already been tested, and you shouldn't feel confident about the performance of the board.
All right. We did have one question that came up there. They were asking about, will this support dual GPUs at full by 16 speeds? The answer is no, I assume.
It's the Ivy Bridge. Yeah, it's the Ivy Bridge.
So there's no bridge chips or anything in here to kind of expand that, right? So, and that's generally the case for pretty much almost all of the Z77 motherboards. Yeah,
any Z77 board, frankly, below 250, it's all going to be like that.
Okay.
But with PCIe, unless this is for folding, unless you want every ounce of performance out of the board, if this is for gaming, you'll never tell the difference.
We did have one other question. I kind of skipped it at the beginning. I forgot about. Will there be an AMD version of this board? Somebody else was asking about an AMD Big Bang motherboard.
Yeah.
Do you have any kind of interesting trinkets on AMD product that you would share?
As far as AMD boards is concerned, I'm fairly certain there won't be one for this current generation of AMD products.
Okay.
There may be one for the next chipset refresh, whenever that is. I don't have too much information about that. Frankly, people that are on forums probably know more about that stuff than I do.
Yeah.
When it comes to time frames and stuff like that, but what it comes down to is if there is a enthusiast SKU that makes sense for this particular board, then yes, we'll make it.
Okay.
That's really what it comes down to.
Okay. I think somebody was saying that you guys actually showed an AMD Big Bang board at one time.
That board ended up being the GD80.
Okay.
We decided internally to change the name because of the way the product was priced. It felt more sense to name it as one of the regular boards than to make a different series out of it.
All right. Well, let's pick our winners real quickly here. Let's see how many entries I need to take from that. So the first one we'll give away is the test bed.
Yeah.
Give away the test bed, and we'll open this to anybody in the country, or I'm sorry, the world, because we're global here, guys. So this test bench, right? Not the specific one.
No.
This one is for me. We use this for our GPU test bed, but this exact configuration here. Let's see. So let's do this. All right. Here is the winner of this one is Mr. Black. Mr. Black. I won't give out your email address live, but make note of that, Ken, for me. Mr. Black won the test bed.
Is somebody in chat going, woohoo, and then you can't hear him because he's going,
I don't know. Hopefully they are. Yes, there they are. Random MIB 5WESD2 says woohoo. And all right, now we'll pick the second one. Let's go to random.org again, generate another number. Okay. Where am I going? Back to the email list. And this is Corey. Corey, I won't give out your full name. Corey S. It is. He says it's very cool that PC Per does this, since the only time people can really see this kind of thing is at QuakeCon, Computex, or other conventions. So we are bringing these kind of presentations.
Yeah. I mean, the thing for me is if it's of benefit to viewers that this type of educational stuff, if there is a value to them, then I'm more than happy to do this more often.
Yeah, I mean we're always going to solicit feedback from our viewers and our readers, right? This is something we're trying to do that's unique. We're trying to differentiate in this fashion. We think it's very interesting to bring these types of presentations, allow company reps to kind of come on and speak to their customers and our readers directly, allow them to ask questions, allow them to be interactive with the chat room, through Twitter, through Reddit, all those types of things. And I think it's been pretty successful. So congrats to Mr. Black and Corey for winning product. Sorry for everybody else. You'll have to hang around for our next live stream. It will not be very far away. We have several of them lined up throughout the next several weeks as well, and it could be all kinds of products. We'll never know. So with that, I guess, anything else, any last words for anybody on any of the products or MSI in general?
Oh, no, that's it. We have, there's more information regarding the board trickling out over the next week or so.
Where's the best place for them to go if they wanted more information
If you wanted more information on it, just check the us.msi.com. Next Tuesday, we'll have the landing page up with all of the product information.
Okay.
As far as pricing, it'll be, like I said, it'll be in e-tail. It'll be $219 to start. It just depends on who you buy from.
Sure. Each retailer is going to be a little bit different.
Exactly, a little bit different on the site on the price, but the MSRP will be $219.
Okay, sounds good. So with that, guys, I want to go ahead and thank everybody for stopping by our PC Perspective live stream. Like I said, we're going to have more of these coming up very soon from all different kinds of vendors. I want to thank Alex again for joining me, and for everybody for hanging out in the chat room and for participating in our questions and answers and all that kind of stuff. Congrats to the winners. More next time. With that, I'm Ryan Schrout, and we'll see you later.